I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on ionic equilibria. So in today's lecture, we'll be looking at the term hydrogen ion concentration, hydroxide ion concentration. So at the end of the lecture, students should be able to define the term hydrogen ion and hydroxide ion concentration, define the terms pH and kW, and use them in calculations. So please, I want us to listen attentively and get the best from today's lecture. So we are looking at the hydrogen ion concentration and the hydroxide ion concentration. The hydrogen ion concentration determines the acidity of a solution. It tells us how strong, how weak the acid is. A solution with a high concentration of hydrogen ion indicates that what the acid is a strong acid. A solution with a low concentration of hydrogen ion indicates that what the acid is what a weak acid. Then when we talk about hydroxide ion concentration, determines the alkalinity of what a solution, whether it's a strong alkali or it's a weak alkali. A solution with a high concentration of hydroxide ion concentration indicates that what is a strong alkali. A solution with a low concentration of hydroxide ion concentration indicates that what is a weak what alkali. So for stronger acid and bases, the concentration of ions is very what high. You have high concentration of hydroxide ion and hydrogen ion. So larger than their weaker counterparts, which only partially will dissociate. So the pH, hydrogen ion concentration, can be converted to what? The hydrogen ion concentration can be converted to pH, which is the negative logarithm to base 10 of what? The hydrogen ion what? Ion concentration. So when you get the hydrogen ion concentration, so you can get what? The pH, which is negative logarithm to base 10 of the hydrogen ion concentration. Then if you have the pH, you can get the hydrogen ion. If you get the pH, you can get the hydrogen ion concentration, which is hydrogen ion concentration, which will now be equal to what? 10 raised to power what? Minus what? Minus pH. So when we talk about hydrogen concentration, it determines the acidity of what? A solution. Then we talk about hydroxide ion concentration, determines the what? Alkalinity of what? A solution. So having considered the hydrogen ion concentration and hydroxide ion concentration, so we want to talk about the pH, which is the power of the hydrogen ion concentration. So the pH is defined as the negative logarithm to base 10 of the hydrogen ion concentration in the solution. In symbols, it is written as what? pH is equal to negative logarithm to base 10 of the hydrogen ion concentration, which is also known as the power of the hydrogen ion concentration. So when you have the hydrogen ion concentration, you can calculate the pH. When you have the pH, you can calculate the hydrogen ion concentration. So to calculate the hydrogen ion concentration will be equal to what? 10 raised to power what? Minus what? pH. So the same thing with the pOH, which is the power of the hydroxide ion concentration. An equivalent calculation for bases converts the hydrogen ion concentration to pOH. So pOH is equal to negative logarithm to base 10 of the hydroxide ion concentration. So when you have the hydroxide ion concentration, you can calculate what? The power of the hydroxide ion concentration, which is the pOH. So when you have the hydroxide ion concentration, you can also what? Calculate what? The pOH. Then if you have the pOH, you can calculate the hydroxide ion concentration. So the hydroxide ion concentration will be equal to what? 10 raised to power what? Minus pOH. So it's as simple as what? ABC. So you can calculate the hydrogen ion concentration given the pH. You can calculate the pH given the hydrogen ion what? Concentration. So you can calculate the pH given the hydrogen ion concentration. You can calculate the hydrogen ion concentration given the pH. The same thing, you can also calculate what? The hydroxide ion concentration given the what? Given the pOH. And you can calculate the pOH when you are given the hydroxide ion what? Concentration. So it's as simple as ABC. So still on ionic equilibrium, we want to look at the ionic product of water. From our previous lecture, we are meant to understand that water is an amphoteric substance. It is capable of acting as an acid and also what? As a base. It can react with an acid to act as a base and also react with a base to act as what? As an acid. So it's an amphoteric substance. Now, despite being covalent, water is a covalent molecule. Water conducts electricity to a very small extent. So it ionizes in solution to generate what? Hydroxonium ion and hydroxide ion. So if you look at what we have here, you see that water acting as an acid reacts with a base to form what? Hydroxonium ion, also known as hydrogen ion and hydroxide ion. So in a more simplified form, it dissociates to give you what? Hydrogen ion and what? Hydroxide ion. Now, applying the equilibrium law to the second equation, equilibrium constant, which is product over reactant. So the equilibrium constant Kc is equal to concentration of the hydrogen ion multiplied by the concentration of hydroxide ion divided by concentration of what? Water. Now, the extent of ionization of water is very low because water is a weak acid and also a weak base. So the extent of ionization is very low. So the concentration of hydroxide ion and hydroxide ion in pure water is extremely small. So because of this, we regard the concentration of water as being what? As being constant. This is an equilibrium constant and the concentration of water is constant. So we'll cross multiply. If we cross multiply, what we are going to get is what? Constant Kc multiplied by constant, which is water, to give us what? Concentration of what? Hydrogen ion multiplied by concentration of hydroxide ion. So we're going to generate a new constant Kw, which is equal to concentration of what? Hydroxide ion multiplied by concentration of what? Hydroxide ion multiplied hydrogen ion multiplied by the concentration of hydroxide ion, which is known as what? The ionic product of water. This constant multiplied by this constant Kc as a constant multiplied by constant water, concentration of water, which is a constant, generates a new constant known as what? Kw, which is the concentration of the hydroxide hydrogen ion multiplied by the concentration of the hydroxide ion to give us a new constant, which is known as what? The ionic product of what? Water. So it's as simple as what? A, B. So still an ionic product of water. Having considered that water, the concentration of water is a constant. So this constant is combined with what? Kc to get a new constant known as Kw, which is the ionic product of what? Water. So if you look at Kw here, will be equal to what? Kw is equal to the concentration of the hydrogen ion multiplied by the concentration of hydroxide ion to give us a new constant Kw, which is what? The ionic product of water. And the concentration of hydrogen ion is in mole per dn³. The concentration of hydroxide ion is in mole per dn³. So the unit for Kw is equal to mole square dm minus 6. And it's a constant, so the value is equal to 1 times 10 raised to the power minus 14 mole square dm minus 6 at 25 degrees Celsius. Now, because the constant is based on an equilibrium, Kw varies with temperature because the equilibrium constant only varies with what? Temperature. Temperature is only a factor that affects what? The equilibrium constant. The equilibrium constant changes with what? Temperature. So Kw varies with temperature. So it's as simple as what? A, B, C. So still an ionic product of water. If you look at the equation for the ionization of water, when water dissociates to form hydrogen ion and hydroxide ion, now you discover that the concentration of hydrogen ion and the concentration of hydroxide ion are produced in equal amounts when water dissociates. So their concentration will be the same. So the concentration of hydrogen ion is equal to the concentration of hydrogen ion is equal to the concentration of hydroxide ion, which is equal to 1 times 10 raised to the power minus 7 mole per dm³. So the concentration of hydrogen ion is equal to the concentration of hydroxide ion. So we can rewrite, the ionic product of water, which is Kw, which is equal to concentration of hydrogen ion multiplied by the concentration of hydroxide ion as what? Kw is equal to concentration of what? Hydrogen ion square. So make hydrogen ion the subject to the formula. Kw will be equal to what? Square root of what? Hydrogen ion will be equal to square root of Kw. And Kw is 1 times 10 raised to the power minus 14. So square root of 1 times 10 raised to the power minus 14 will be equal to 1 times 10 raised to the power minus 7 mole per what? dm³. So the concentration of hydrogen ion is equal to 1 times 10 raised to the power minus 7, and the concentration of hydroxide ion is equal to what? 1 times 10 raised to the power what? Minus 7. So the equilibrium constant Kw is equal to what? A concentration of hydrogen ion raised to power 2, which is equal to the square of the concentration of hydrogen ion, or square of the concentration of what? The hydroxide ion. So we can use it in what? In calculation. So please, I want us to take note of that the Kw is equal to what? concentration of what? The square of hydrogen ion. So it's as simple as what? A, B, C. So based on our lectures for today, these are typical examination questions for us to attempt based on what we've studied. Now use the value Kw to calculate the concentration of hydrogen ion in pure water under standard conditions. You have to show your workings. So the first thing for us to do is to write down the formula to calculate the ionic product of water, Kw. So we want to use Kw to calculate the concentration of hydrogen ion. So writing down the formula, Kw will be equal to what? Square of the hydrogen ion concentration. Square of the hydrogen ion concentration. So we have to calculate hydrogen ion concentration. So hydrogen ion concentration will be equal to what? Square root of what? Kw. And our Kw is a constant which is known as 1 times 10 raised to the power minus 14. So which will now be equal to square root of what? 1 times 10 raised to the power what? Minus 14. Which will now be equal to what? 1 times 10 raised to the power what? Minus 7 mole per dAq. So it's as simple as what? A, B, C. Now let's look at the next question. The pH of pure water at 50 degrees Celsius is 6.64. Calculate the numerical value for Kw at what? 50 at 50 degrees Celsius. So what happened? Use our formula. The first thing we need to do, we need to calculate the concentration of hydrogen ion. We are given the pH. So concentration of hydrogen ion will be equal to what? 10 raised to the power minus pH. So the concentration of hydrogen ion will be equal to 10 raised to the power minus 6.64. So I'm to use my calculator now. 10 raised to the power minus 6.64 minus 6.64 which is equal to 2.29 times 10 raised to the power minus 7. So the concentration of hydrogen ion is equal to what? 2.29 times 10 raised to the power what? Minus 7. So we have to calculate Kw. And we know from the formula Kw will be equal to what? The square of hydrogen ion concentration. So we have to calculate, which will now be equal to square of what? 2.29 times 10 raised to the power minus 7. Minus 7. 2.29 times 10 raised to the power minus 7 square. The square of 2.29 times 10 raised to the power minus 7. Square of 2.29 times 10 raised to the power minus 7. You know, Kw is equals to what? The square of the concentration of the hydrogen ion. And the hydrogen ion is 2.29 times 10 raised to the power minus 7. So we have to square it. So I have to use my calculator. So if you square 2.29 times 10 raised to the power minus 7, you are going to get 5.25 times 10 raised to the power minus 14. So Kw will be equal to what? 5.25 times 10 raised to the power minus 14. 5.25 times 10 raised to the power minus 14 mole squared dm minus 6. So it's as simple as what? A, B, C. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So based on the lecture and based on what we've discussed so far, so these are typical examination questions for us to attempt. Please attempt the following questions and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you for listening.